Hi everybody, welcome to our video lesson on using probability models. Today you're going to want to have some paper, whether that's your math notebook or loose leaf paper, and a pen or a pencil to take some notes. We're going to be doing a couple of sample problems, couple of vocabulary, and then we're going to send you on your way to try some practice on your own. So you might be wondering, what is a probability model? Well, a probability model is a mathematical representation of an event. It's defined by its sample space and probabilities associated with each event. The sample space S for a probability model is the set of all possible outcomes. Now, the probability model we're going to be using today is in the form of a table where we have the possible outcomes on the top and the probability of each of those outcomes on the bottom. Let's take a look at an example. So in the example that we're looking at here, we've got a spinner that has 5 sections with 5 different letters. Each of those sections looks like they are the same size. So the possible outcomes are we could land on the letter G, the letter J, the letter K, the letter F, or the letter R. Remember that probability is the number of ways the event can occur over the number of possible outcomes. So the probability of landing on a G is 1 out of 5. There's only one G out of 5 different sections. The probability of landing on a J is also 1 out of 5. Same for K, same for F, and same for R. Let's go ahead and jot down these 2 definitions. Uniform probability model. So a uniform probability model is when all the probabilities in the model are equal to one another. We just saw in the spinner problem that we looked at a uniform probability model. That would be considered a uniform model because all of the probabilities were 1/5. They were all equal to one another. In a non-uniform probability model, this is when not all of the probabilities are equal to each other. We'll take a look at an example of that in a little while. If you need to, please pause the video right here so you can get these definitions written down in your notes. So, probability models can help us solve problems with probabilities. They're kind of like a graphic organizer, but for math problems involving probability. So let's take a look at this example. This example is about randomly selecting a painted rock from a bag containing 4 purple rocks, 3 green rocks, 3 orange rocks, and 2 blue rocks. Now, the possible outcomes are what is listed on the top of our table. And I would encourage you to pause the video right now and go ahead and create this table in your notes. You can resume the video as soon as you're ready. Okay, there are purple rocks, green rocks, orange rocks, and blue rocks. Okay, if I look at the total number of rocks there are, looks like we have 7, 10, 12 total rocks. 4 are purple. So initially, we can say that we have 4 out of 12 rocks being purple. Remember that if we can simplify our probability fraction, we should. So our probability of picking a purple rock out of the bag would be 1/3. Green is 3 out of the 12 possible rocks. Again, if I simplify, that would be 1/4. For orange, we also have 3 orange. So that's going to have the same probability as green at 1/4. and then we have 2 blue out of the 12 rocks, which would give us a probability of 1/6 of selecting a blue. Now, we can use that model to help us determine each probability. So let's take a look at these sample problems. Number 1 says probability of choosing a black rock. Well, we don't have any black rocks in the bag, so what do you think the probability of selecting a black rock is? If you said 0, you are absolutely correct. Number 2, what is the probability of picking a purple or a green? Okay, so we can find this out by adding the 2 probabilities of purple and green together. So, probability of purple plus probability of green is going to give us the probability we need. So our purple is 4/12, and our green is 3/12, which gives us a total of 7/12. So the probability of picking purple or green will be equal to 7/12. Now notice that I kept those probabilities in their original form because that way they both have a common denominator already. It just makes it a little quicker to add them up. All right. Example 3 says, what is the probability of selecting a primary colored rock from the bag? Well, that would require us to know our primary colors. So primary colors are red, yellow, and blue. Okay, so we have probability of blue, and guess what? We don't have red or yellow. So the probability of picking a primary color is simply going to be equal to the probability of choosing blue. So our probability is 1/6. Now, question 4 deals with our vocabulary terms. Is this a uniform probability model? I'm going to pause for just a minute so you can think about that. Hopefully you said no. This is not a uniform probability model because we do not have all of the same probabilities. All right, guys, we're going to take a look at just one more example before we get you started on your work. So in this example, we are looking at randomly selecting one of 5 members of a hockey team to take the first shot in an overtime shootout. Okay, so the possible outcomes are we could choose player number 1. We could get player number 2, player number 3, number 4, or number 5. Okay, they're telling us 1 out of 5. So that means our probability for each of these is 1/5. There's only one player number 1 out of 5 possible players. Only one player number 2 out of 5 possible players, etc. All right, we're going to use the model to help us determine the probabilities. Let's take a look at calculating the probability of choosing player number 4. Okay, well, we know from our table the probability is equal to 1 out of 5. Okay, the probability of an odd player number. Okay, we have the odd numbers 1, 3, and 5. So we need to look at the probability of number 1 plus the probability of choosing player number 3 plus the probability of choosing player number 5. Those are all of our odd numbered players. So 1/5 for each of them means that our total probability is going to be equal to 3/5. The probability of choosing an odd numbered player is 3/5. All right, number 3, the probability of choosing not player number 4. Now, remember when we are looking at the not situation, what this really means is we're looking at the complement. So the probability of not choosing player number 4, if you remember from our previous lesson, is going to be equal to 1 minus the probability of choosing player number 4. So that's going to be equal to 1 minus 1/5, which is the same as 5/5 minus 1/5. So the probability of not choosing player number 4 is going to be equal to 4/5. All right, last but not least, is this a uniform probability model? Okay, if we go back up and take a look at all of our probabilities from our model, all of them are equal to 1/5. So our answer to this question is yes. Because all of the probabilities were equal, this is a uniform model. All right, ladies and gentlemen, I think you have enough to get started on today's work. I hope you have a great day.